part, right? So in this, kinetics HL, we know that in any reaction, this is the reaction. Any reaction will be having a series of multiple steps, right? Where C, D, I mean A goes to C, then C goes to D, and D goes to E, and after that E goes to B. These C, D, and E, these are called as intermediates, right? Understood? Why
Yeah,
intermediates? This is
because they're used
generated
up
in the
in the
first step.
reaction.
This is used in the first, generated in the first step and used in the second step. D is generated in the second step and used up in the third step, right? E is generated in
Yeah,
the third step and used up in the fourth step, right? So these are called as intermediates. Intermediates will not be reflected in the main equation, right? Clear? Get my point? Understood? This is clear to you? This
yeah,
won't reflect, right? Now, this is a theory, right? Which is backed up by some evidence, but this is a theory, 100% theory, right? Clear? This
yeah,
entire series of the steps is called as a reaction mechanism. Got it? Is it clear? Do you get my
yeah,
point? Entire series of the steps is called as the reaction mechanism. Understood this part? Understood?
yeah,
So it's a very important portion we have to learn, right? This entire series of the steps is called as a reaction mechanism. That's a very, very important part for to master, right? Clear?
yeah,
Anything, please tell me. Is it clear to you over here, right? This entire series of the steps is called as reaction mechanism, right? Fine?
yeah.
Understood? Now you will be getting what you'll be getting the steps, right? You'll be getting. You don't have to make the steps. See, this is the main reaction. This reaction has in two steps, right? Isn't it? Now, how to
Yep.
find out the intermediate? We have to find out the intermediate of how to find out the intermediate. The species
Uh,
which is not shown over here, right? Species which is not shown over here, right?
yeah,
Sorry, the species which is here is not here.
but not in
That is
the
not
overall.
in there, right? Can you tell me that over here, which species are here but not here? Those are the intermediates. Can you tell me?
Uh,
No, 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 no,
these
wait, wait, wait,
NO2,
wait, wait,
NO2 and
wait, wait, wait,
NO3.
wait, wait, wait. NO2 is not here. See, here, already here. So how can it be intermediate? I told you what intermediates are those which are here but not here. Got it?
Yeah,
So which is the intermediate? Tell me.
NO3.
NO3. Got it? Get my
Yeah,
point? Now remember one thing that we have to know something about molecularity of a reaction. What's the molecularity of a reaction? The the number of the reactant molecules involved in a step is called as the molecularity of a reaction, right? Did you get my point?
yeah, yeah,
If there are two molecules, right? If there are two molecules which are involved, right? If there are two molecules which are involved, right? Isn't it? Then this
yeah.
is bimolecular, right? Clear? If there is one molecule involved, suppose this step is this. So how many reactant molecules are involved in this step? One. So it will be unimolecular, right? Clear? Understood this thing, Ola?
Yeah.
Get my point? Got my point? Understood this part? Clear?
So because it's an intermediate, it's that
No, no, no.
the
Don't,
then
no, 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 no. No. I'm talking about something else. Molecularity. What is this called as molecularity? Is the number of reactant species involved in a step. Reactant molecules. How
yeah,
many? How many? How many reactant molecules are involved in this step? Step number one,
two of them.
two. So this is bimolecular, right? Right. Suppose you have got only one molecule involved. Suppose this was not there. The step number one. So this is only one reactant molecule involved. So it is unimolecular, right?
Yeah,
Clear? Is it clear to you? Did you get my point?
yeah.
So
So
always remember
both
that.
step one and two. So
If you,
so both step one and two are bimolecular.
yeah,
Bimolecular.
bimolecular, right? Very good. So if you add step number one and step number two, what happens? You're getting the total main reaction over here, right? This will match, right?
Yeah,
Now,
and
in
I could say
any
that's also bimolecular.
no, the molecularity will be. I'm telling you that molecular will be the intermediate, the elementary steps, right? We don't call molecularity for this reaction, main reaction, right? No,
Okay.
molecularity will be only applicable. Further, you'll be learning molecularity will be only applied for the slowest step, right? This slowest step. Understood? Clear?
Yeah,
Understood? We have to find out. We have to tell the molecularity by the of the slowest step, right? Clear over here? Did you get my point?
yeah,
Huh? The second thing is that if you see when we talk about there are two steps. One of the step will be a slow step. Agreed? Fine.
yeah,
And one of the step will be a fast step. Right? Clear? Understood? Or vice versa. You get my point, right? One of the
Yeah.
step will be slower, one will be faster, right? Both of them won't be having the same speed, right? One of them will be having a slow step, one of them fast step, right? Clear? Is it clear till now? Agreed?
Yeah.
Now next is that if you see when we talk about this, right? We have to also understand a very crucial thing over here, that if you want to change this rate, right, this rate reaction of this reaction, what you have to do? We have to increase the rate of the reaction of the slowest step, right? Do you get my point? Because if one step is slow and the step is fast, which step you have to improve upon to increase the rate of the reaction, overall rate of the reaction? Please tell me.
The slow one.
Slowest step, right? Why? Because in the slowest step, the speed of the reaction becomes slower, very slow. Here in the
Yeah.
second step, it's fast. So if you increase this speed, will it affect this whole reaction? No. Do you get my point? Suppose you are
Yeah.
in a city, there is a traffic signal, two traffic signals, right? One is a village crossing where there's very less amount of people around. One is a busy marketplace and an office area, right? Signal A, signal B, right? Now, if you want to improve the city traffic, which signal you have to improve upon? It's the busy market area and office area where the cars they queue up, right? And here this is a village signal, right? There's no people around staying. So
Yeah.
if you want to improve the city's traffic, which signal you have to improve upon? Tell me. A or B?
Uh, which is one
Did
A?
you get my
Was it?
question? Yeah, A. Because why A? Because in B, the car zoom past, right? You don't have to
Yeah.
improve this signal. You have to unclog this slowest step. Understood? Understood. Because the slowest step is where the reaction becomes much slower, right? Now, from the
Yeah.
enthalpy level diagram, you can also understand that which is the slowest step, right? Get my point? From the enthalpy level diagram, also you can understand how. Now, remember this thing. This has got an enthalpy level diagram of this, right? So, how many steps are there? You can note from the two humps. How many steps? Two steps are there,
Two
right?
steps.
Now, the highest energy of the transition state. You get my point? The highest energy of the transition state, right? Did it?
Yep.
That will be the slowest step, right? Which transition state is higher? Step number one,
First step.
transition. Got it? Is it clear how to find out the slowest step, right? Clear?
Yeah.
And always remember that this is the step. This is the step. The slowest step will be the rate determining step. Is it clear? Understood? RDS. Understood why? Because the reaction becomes slowest over here. So everything you have to concentrate to improve upon the first step, right? Because the second step is the fast step. It zooms around. It zooms past, right? Clear? You get my point?
Yeah.
Understood? The first step is the rate determining step, right? Is it clear? Understood?
Yeah.
Do you get my point? And you have to understand that the slowest step, right, is the rate determining step. And see, can you see this in the starting that the order of the reaction, did it have any linkage with the stoichiometry? It didn't have, na? We
No.
took to this rate is equal to k a to the power what m and b to the power n. So did we discuss that okay m and n are the order of the reaction? Does it have
Yeah.
any relation with the x and y? Does it have x and y? It does not, right?
No.
So now we have to understand why. That why, where does it have a relation with, right? So if you have got this reaction, and this is the two steps, slow step is this, fast step. You'll be given already, right? You don't have to determine. Slow and fast will be given, right? Remember one
Okay.
thing: the slowest step is the rate determining step, right? And the rate expression of this step to the power of stoichiometry of the reactant, that will be the rate expression of the entire reaction. Shall I come back again? Can I come back
Yeah.
again? The rate expression of the rate determining step, or the slowest step, what is that? Rate is equal to what? K to the power NO2Cl to the power of
NO2CO.
1. Understood? To the power of
Yeah.
stoichiometry. Isn't it? Because at this step will influence the other reactions, right? Clear? Did you get
Yeah.
my point? The rate expression of the slowest step to the power of stoichiometry, that will be the rate expression of the entire reaction, right? Clear? Is it clear?
Yeah.
Fine. Now can you find out the rate expression? Do it of
The
this.
rate equation.
This is the question. Do it. Did you understand this part? In this
Yeah.
reaction, what happens? We have got fast step and slow step. So slowest rate means rate will be equal to K into O2 to the power of 1 and O to the power of 1. But N2O2 is a intermediate. We cannot keep an intermediate to represent this entire reaction rate, right? We go to the first step. This is coming from NO and NO. So replace this, rate will be equal to K, NO to the power of 2 and O to the power of 1. Is it clear? So
Yeah,
that's the way we have to replace the intermediate, right? Clear? Now see, suppose
yeah.
the past paper question will be something like this, similar to this. Tell me. See, can you tell me this?
For 23.
Mhm. I already told you that this is the rate equation is what? Tell me. Rate equation is what? Tell me. Already told you. Second order reciprocal. Can you write
Yeah, it
down the
is.
rate expression? K into NO2 to the power of 2. Understood?
Yeah,
So is this consistent with this mechanism? What do you think?
yeah, it's consistent.
Yeah, right. Brilliant answer, right? Can you tell me question number 24?
24. I'm not sure if one is correct because because what is it? The different steps of the reaction might have different uh and it might have like intermediates and then
Wait, which
2SO2.
statement is, let me tell, right? Which statement is going to follow reaction? The reaction must involve collision between O2 and 2SO2. Can we be sure of
Yeah.
this? Do we have
Okay.
any do we have any reaction mechanism over here? We don't have.
No.
We don't have. This is the main reaction. Do we have any split it up? Step one, step two? No. So we don't know, right? Clear? Get my point?
Yeah.
Every collision between SO2 and O2 will produce SO3. Is it? Do we have? Do we have any reaction per mechanism? You have it. You have.
Sorry?
Do we have any reaction mechanism of this? You
No.
have? No, we don't have. Can we predict that every collision of SO2 and O2 will be producing SO2? No, not
No.
really, right? Got it? Is this the right
Yeah.
answer? See, wait. Yeah, slowest movement. Is it clear? Got it?
Yeah.
Get my point? So, so we all do what? We are trying to, yeah, can't predict because there's no reaction mechanism given, right? Clear?
Yeah.
Now, can you do this quickly? Can you do this? Huh? Do this. I'm just coming back right 1 minute. Get my point. First step, rate expression will be the K into AB2, the power of 2. Wonderful. To get the overall overall reaction, whatever, we add up these two steps, right? Hmm. Get my point.
Yeah.
To find out the rate constant, what you do? Rate divided by concentration of AB2 to the power of 2 is equal to whatever cancels out and all, right? Is it clear?
Yeah.
Now you're strong in this, right? Okay. Fine.
Yeah.
Fine.
But
Thank you.
I also wanted to